Okay, for problem number 1, we're given the values of the variable, which is x equals -2 and y equals -4. So we're going to stick those in. Remember, anytime you replace a variable with the value given, put it in parentheses. It's going to keep track of the sign better. So -2 for x, -4 for y. Order of operations says multiply left to right. 2 times -2 is -4. -5 times -2 is +10 times -4 is -40. -4 minus 40 is -44. One down. Problem 2, same idea. This time x is 3, y is -1. We're going to put them in here. 2 times x, which is 3, plus 3 squared minus 12 times -1. Okay, so 2 times 3 is 6, plus 3 is 9. We simplified the parentheses, so we're getting 9 squared minus 12 times -1. 9 squared is 81. -12 times -1 is +12, and 81 plus 12 is 93. Okay, problem 3 and 4 says solve by combining like terms. So again, we use order of operations, which means we're going to distribute first. So 2 times x is 2x, 2 times -3 is -6, okay, plus 5x minus 15. Now, like terms are going to be those that have the same variable. So 2x, positive 2x, positive 5x gives us 7x. -6 and -15 gives us -21. And we're done. Same thing over here. We have 7x squared minus 9x plus 2. And now this parentheses, this whole thing is being subtracted. So what I'm going to do is distribute the negative and write the common terms under them. Okay, so this would be negative x squared minus -2x, which is plus 2x, minus 3. And then I can just add our common terms. 7x squared minus x squared is 6x squared. -9x plus 2x is -7x. 2 minus 3 is -1. There we go. Here, we're solving equations. So in order to solve the equations, we need to simplify both sides. So the left-hand side, nothing's really being done to it. It's 2x minus 6. Over here, we're going to distribute -2 times x is -2x. -2 times 6 is -12. We want to get the x's on one side and the constants on the other. So I'm going to add 2x to both sides. These guys are going to cancel out. 2x and 2x is 4x. And then I'm going to add 6 to both sides. That cancels. -12x plus 6x is -6. We want the x by itself, so we need to divide both sides by 4. We get x equals -6/4. Fractions need to be simplified. So both -6 and +4 have 2 as a common factor. The 2 factors out, and it reduces to -3/2. Okay, fractions have to be simplified. This guy, same thing. We're going to simplify left-hand side. So 2 times 2x is 4x. 2 times +3 is +6. And then don't forget that -x equals 2 times 3x is 6x. 2 times +2 is 4. Simplifying over here, we have +4x and +4x and -x is 3x plus 6 equals 6x plus 4. Bring the 6x over, subtract 6x from both sides. 3x minus 6x is -3x. Subtract 6 from both sides. 4 minus 6 is -2. Divide both sides by -3. X equals -2/3, which is +2/3. A negative over a negative is a positive. Okay, so inequalities, again, we need to solve for x, but this is an inequality. we're just going to do this. Distribute here. 4 times 4 is 16. 4 times positive x is positive 4x. We want to get the x on one side and leave the constant where it is. So I'm going to subtract 4x from both sides. These guys cancels. X minus 4x is negative 3x. It's greater than or equal to 16. So I want x by itself. So I need to divide both sides by negative 3. Now remember, whenever you multiply or divide both sides of an inequality by a negative, the direction of the inequality switches. So x is less than or equal to negative 16 thirds. On this one, again, we're going to distribute negative 6, negative 3 times negative x is positive 3x. We want to get the x's together, so subtract 3x from both sides. These guys cancel out. 3x minus 3x is 0. So 0 is greater than negative 6, which it is, because 0 would be to the right of negative 6 on the number line. So this is a true statement, meaning our answer is all real numbers. Okay, find the slope of the line. If it contains the points, we're going to use the slope formula, which is m, slope, is equal to y2 minus y1 over x2 minus x1. It doesn't matter which one you call point 1 or point 2. What matters is if this is point 1, that's x1 and that's y1, and if this is point 2, that's x2 and that's y2. So I'm going to go 4 minus 5 y2 minus y1 over negative 2 minus 3 x2 minus x1. 4 minus 5 is negative 1. Negative 2 minus 3 is negative 5. So the slope, negative 1 over negative 5, is positive 1/5. Okay, for number 10, this is the equation in standard form. Our standard form is ax plus by equals c, where a, b, and c are integers, and a is positive. And when it's in standard form, you can get the slope by the formula m equals minus a over b. So m is going to equal to minus a, so negative 3, over b, negative 5. So if we're getting m is equal to negative 3 over negative 5, that would make it positive. And the slope is 3/5. Okay, for this guy, we're graphing the line, and this equation is in slope-intercept form. So the slope, this is y equals mx plus b. So the slope would be equal to 3/4, and the intercept would be equal to negative 4. So when negative 4, that's the point 0, negative 4, 1, 2, 3, 4. So we're down here, okay, and if we're using the slope, which is positive 3/4, we would go up 3, so 1, 2, 3, up, and 1, 2, 3, 4 in the positive x direction, and we get our slope like this. Remember, for a graph, you must label the points. 1, 2, 3, 4, negative 1. If you don't label the points, it gives you 0 points. It's art, not math. Label the points to get full credit. Okay, so in the system of linear equations by the elimination method, this is a specific method. To use elimination method for a system of linear equations, remember these lines are either going to intersect at one point, they'll intersect at 0 points, meaning they're parallel, or they'll intersect at every point, meaning they're coinciding. Okay, to use elimination, we want to get the coefficients on one of the variables to be opposites. So in our equation, we have a positive 4y and a negative 4y, so those are already opposites. If we add these lines together, 3x plus x is 4x. Negative 4y plus 4y is 0. That variable dropped out. And 12 plus negative 2 is 10. Dividing both sides by 4, we get x equals 10 fourths, which reduces to 5 halves. So we have our x value. So go back to either one of the original equations, whichever one's easier, and stick in 5 halves for x. So x plus 4y equals negative 2. Now we're going to solve this equation for y. So subtract 5 halves from both sides. That cancels out. Over here we're getting 4y. In order to subtract a fraction, we need to write negative 2 as negative 4 over 2. So negative 4 over 2 minus 5 over 2 is negative 9 over 2. We want y, not 4y, so I'm going to multiply both sides by 1/4, which is just like dividing by 4, but it's easier because you're multiplying fractions, which gives us y equals negative 9/8, which is our y value. But remember, the solution is where the two graphs intersect, the point. So our answer is actually the point 5 halves negative 9/8. This would be their point of intersection. Okay, determine if the graph is a function and explain your reasoning. Now remember, if it's a function, for each x, the graph should give one and only one y, meaning it has to pass the vertical line test. So anywhere you can draw a vertical line, you can hit the graph in only 1 point. Over here, that's fine. Here, we're hitting 3 points. Here, 3 points, 3 points, 3 points. So since this does not pass the vertical line test, okay, the graph is not a function. Okay, so determine the range of the graph. We're gonna say these guys actually have arrows on the ends of them because they should. Okay, so to get the domain, remember the domain just all the possible values of x. So here, this graph is increasing, right? Increasing towards negative infinity, increasing towards positive infinity. So the domain is all real numbers. The range are all the y values of the graph. Well, it goes to negative infinity in the y direction, right? That's negative infinity. But it only goes up this high. Okay, so what it means is y must be less than or equal to whatever this value of y is, which is 1, 2, 3. So y is less than or equal to 3. Domain is all real numbers. Range, y less than or equal to 3. To simplify radicals, this is the square root of 27xy to the 7th. So I'm going to put everything under here in terms of squares. Well, 27 is 3 cubed, right? Or 3 squared times 3, right? 9 times 3 is 27 times x. So we have 7 y's, right? So if I go y cubed squared, that's 6 of them, right? Times y, that's 7. Now, anywhere there's a square, the index on the square root, and the variable, the exponent on the term under the radicand will cancel out. So the square root of 3 squared is 3. That can come out from the radical. This guy's gone. This stays in, this stays in. The square root of x cubed squared is this base, y cubed squared, is y cubed. So that whole term comes out. This stays in. So 3y cubed is on the outside, and 3x y stays under the radical, and we just simplified it. In this case, it's a cube, so we want to write everything under the radicand as a cube. 8 is 2 cubed. X is just x. Y to the fourth can be written as y cubed times y. And again, if the index and the exponent are the same, they basically cancel out, so it brings them outside the radical. So cube root of 2 cubed is 2. That comes out. This stays in. The cube root of y cubed is y. That comes out. Takes care of that. This stays in. So 2y times the cube root of xy. With this one, we have a binomial containing a radical in the denominator. So to rationalize this, we have to multiply by the conjugate. Remember, the conjugate is the same terms, 5 and radical 3, but the sign between them is going to be different. Okay, so I'm going to go 3 over 5 minus radical 3. And multiply top and bottom by 5 plus radical 3. Okay, again, that's the conjugate. Terms are the same. Sign between them is opposite. So then we just multiply numerator times numerator, denominator times denominator, and we'll get rid of the radical. Okay, so 3 times 5 is 15. 3 times positive radical 3 is 3 radical 3. There's the numerator. In the denominator, 5 times 5, 25. 5 times positive radical 3 is positive 5 radical 3. Negative radical 3 times 5 is negative 5 radical 3. And negative radical 3 times positive radical 3 is negative radical 9, which is negative 3. These cancel out. They're opposites. So in the numerator, we're getting 15 plus 3 rad 3 over 25 minus 3, which is 22. In this case, since 15, 3, and 22 don't have a common factor, we know we're reduced, and we're done. On this one, reflecting the graph across the x-axis and its user chart to show which points are being used for the reflection. So for the graph that's shown here, I'm just going to pick some points, right? I'm going to go this one, which is 1, 2, 3, 4. It's like negative 4, 0. And this one, 1, 2, 3, which is like negative 3, 4. This guy, negative 1, goes through the origin, 0, 0. It goes through 1, 2, right here, and we'll call this roughly 2, 1. Okay? Now, if it's reflecting across the y-axis, that means this thing is rotating left to right. Okay? So the y values will stay the same. So on our reflected graph, the y values stay the same, and the x values will be the negative of what they are. So we will get positive 4, 0, positive 3, 4, positive 1, negative 1, 0, 0 just stays, negative 1, 2, negative 2, 1. We plot these guys, 1, 2, 3, 4. Oh, sorry, this was negative 4. My bad. Okay, so we'll go 3, 2, 3, negative 4, 1, negative 1, 0, 0, negative 1, 2, and negative 2, 1. And then you just sketch the graph as close as you can. And our graph looks like that. So this thing just literally flipped right around the y-axis and looks like that. Okay, for this guy it says first draw the parent function, which is f of x equals x squared. So remember, for the parent function for a quadratic, we're going to use 0, 0, plus and minus 1, 1, plus and minus 2, 4. So we get this graph. which looks like that. Okay. Now, for the transformed function, which I'm going to put in red, we have a couple things going on. So first of all, this minus says it's reflected. So it's reflected across the x-axis. Okay, this is like x minus h. So x minus 3, h is 3, so it shifts right 3 units. And this is plus k, so plus negative 2. So this means it shifts down 2 units. So I'm actually entering 20 as I'm doing 19. Okay, so first I'm going to do is I'm going to look at this. So if it's reflected, that means reflected across the x-axis, that means the y values would become negative. So our first one is 0. Negative 0 is still 0. Okay, but then it's going to move. It's going to move 3 units to the right and 2 units down. So we're going 3 units to the right, there's x, and 2 down. 1, 2, 3, 1, 2. So this is our vertex. 0, 0 is moving 3 to the right and 2 down. Okay, it's reflected, right? So everything's going down relative to here, right? If we look at this y value, this one, it's going to become negative 1, right? And then 3 to the right and 2 down. This one, reflected, so it becomes negative 1, 3 to the right, and 2 down. Okay, this value, right, since it's reflected, it will go to negative 4, and then 3 to the right, and 2 down. Okay, this guy, reflected, 3 to the right, 2 down. So we get our graph that looks like that. So what points are these? We're getting 3, negative 2. We're getting 4, negative 3. We're getting 2, negative 3, 5, negative 6, and 1, negative 6. So we just answered 19 and 20. Good job.